Hello and welcome to another episode of the Fully Charged podcast. This is great fun. I'm enjoying this too much. It's not right, but what I'm hoping is that my joy is transmitted through the interwebs to you, the wonderful audience and listeners of this very, very lovely series. Just before we start, I just want to mention the old podcast thing where you leave a review if you want to. No pressure, genuinely no pressure whatsoever. But if you are of a mind to leave a review, we've had some wonderful reviews, and it does help us. We get a little bit of a boost, particularly if you leave them on Apple Podcasts. If you use the elitist, exclusive walled garden of Apple products, which crush your freedom and exclude normal, hardworking families. Or not, as the case may be. But there's lots of different ways. So I use a thing called Downcast, an app called Downcast, which is where I get all my podcasts from, and it updates automatically if I subscribe to them. So that was my second thing. I was going to say, do subscribe. Then you won't miss any of these fabulous shows that you can listen to at your own convenience. It's not like radio, where it was on at 9:30, and if you weren't there when it was on, you didn't hear it. That's for the older members of our audience. We are having our first awards night in Amsterdam, the Fully Charged Awards. And this is going to be voted for by not by some industry professional or some member of the super elite. This is voted for by our viewers on the Fully Charged Show, on the Fully Charged podcast, on the Everything Electric channel. We will be promoting it through all those ways, and there'll be a simple form for you to fill in, blip, 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 tick the box, to vote for loads of different categories. And even the categories are being suggested by our viewers at the moment. So that happens in Amsterdam when we're also doing our big live show in Amsterdam. And that show is going to be absolutely groundbreaking, huge. So we did one last year, which was modest but successful, our first year in Amsterdam. And this second year is going to be really, really big. And so many cars coming. We've had to hugely expand the amount of space that we take up in the Rye Exhibition Centre, which is in southern Amsterdam, sort of near the middle anyway. That's not coming till November, so we're not going to worry about that. We are here today to talk how you heat big apartment buildings in the North American continent. So Canada, Northeastern America, really interesting stuff going on there. Heat pumps that heat buildings, but not a house, because we all know, we're all familiar on the Fully Charged Show with a heat pump that heats your house. This is a heat pump that heats an apartment in a massive building with hundreds of apartments. And who pays for that? And who runs it? And how is it done? I was absolutely fascinated to find out this. This is something I hadn't thought of in a typical narrow blinkered world that I live in, like that. I don't know. Do people live in apartments? I've never met them. Yes, they do. Lots of them. In fact, huge numbers of people live in apartments in cities all over the world. And one of the important things we've got to do is either keep them warm in the winter or keep them cool in our very, very hot summers. And one of the brilliant ways of doing that is with air source heat pumps. And we are going to be talking to today the amazing couple of people who have founded and run Bondi Energy. They're based in Toronto, but they work all over North America. And when I say North America, I'm talking geographically, not nationally. So Canada and the United States. Belinda Gilbey is the founder, and Aaron Graben is her partner, who runs this amazing company. They are really, really interesting. We had quite a struggle to record this episode. Not today, it's gone really well, but in the past, we've had 3 attempts. And it's not their fault, it's not my fault. It just happened. It was internet connections just being difficult, which we don't normally have a problem with, but we did that. But today we had a perfect experience of chatting across the Atlantic Ocean, and it was really, really good. They're amazing people, really interesting stuff. Please do welcome onto the Fully Charged Show podcast, Belinda Gilbey and Aaron Graben. Aaron and Belinda, thank you so much for persevering. I think it's fair for us to tell our audience that we've gone through some hoops to get to this point, but I know it's worth it, and it's really, really good to see you and really good to hear what you're up to. So can you I think. Well, can I start with you, Belinda, to explain what Bondi Energy is, and where it comes from, your background, and how you got into this particular area? Because what you're doing, I think, is incredibly important, and it needs to be heard.
Yeah, for sure. Thanks, Robert. So my name's Belinda Gilbey. My background's in mechanical engineering and worked in the renewable energy field for a number of years after I graduated from university, and then got into HVAC. And that's where I learned all about heat pumps and air source heat pump technology. And long story short, Aaron and I met one day. He was a customer of mine and building owner, and I was sharing some ideas that I had in the space, and we decided to go out on our own to start Bondi Energy, which has a focus on retrofitting multifamily and commercial buildings with heat pumps and other energy efficient technology. So we work directly with building owners, typically, institutional landlords, senior care facilities, pension funds, big property owners, to retrofit their older buildings to make them more energy efficient using, tools like heat pumps and, doing windows and domestic hot water, and just making them more energy efficient and decarbonizing.
And I think I want to point out to our wider audience that you're based in Toronto. Am I right? Is that what we see out of the window behind you?
Yeah, that's
the Toronto skyline.
It's a little foggy today, but otherwise you'd be able to see the CN Tower.
Oh, right. But I think the point is that you're retrofitting old buildings in a climate that can be extremely cold, and you're using heat pumps to do it.
Yeah, and we're also in New York, Chicago, Detroit,
right,
Vancouver. So we're in these colder climates where heat needs to be changed to electric.
Yes, but I mean that is interesting, because I think a lot of this. I'm very aware of the kind of penetration of heat pumps in Northern Europe, which is huge. I mean, there's millions of them, and when they were first suggested in this country, everybody panicked and went, "They won't work. It's too cold." And you go, "Well, try living in Sweden in the winter. It's a bit chilly there." So they do. But what is interesting, I've only ever seen and come across either domestic heat pumps that you would put in one individual house, or really like huge heat pumps that take river water and extract heat like that. I've seen a company in Scotland that makes those, that are fitted in Norwegian towns in fjords, and they're extracting water so cold. The water is so cold, and yet they can still produce heat. So,
yeah.
But are most of the heat pumps you're using air source heat pumps?
Yeah, there's a lot of different types of heat pumps, and that's defined on where you get the heat or cooling energy from. So either from the air, from water. So if geothermal systems, those are taking the heat or heating or cooling energy out of the ground. So there's lots of different types of heat pumps, but effectively work in similar ways. Our experience has been primarily with air source heat pumps. They're much easier for retrofitting existing buildings, because you can put a compressor outside and the indoor units inside. And, certainly around the world, there are a lot of heat pumps installed in single family homes. There's less penetration in the multi-family and multi-unit commercial building space, but that's what we're working on. We're looking to increase market uptake of heat pumps in large buildings.
But then, so all the air source heat pumps I've seen, you've got a box outside the house.
Yeah.
With which and then equipment inside the house. But I mean, so when you're doing something on the 28th floor of a large building, do you then strap a box on the outside of the building? I mean, how is it technically done? That's really fascinating.
Yeah, sort of. So a lot of the buildings we work in on balconies in all the apartments. Right. So we'll put the outdoor unit on the balcony, and sometimes we'll put a nice aesthetic cover over it so it looks better and blends in with the building, paint it. But there's an outdoor unit, and then that's connecting to the indoor units, which are, blowing the cold or hot air around the state.
And so I suppose that we should mention that it's important. It's both ways. It can heat or cool a building. It's not just heat.
Yeah, exactly. When you think of the name heat pump, that's literally what it's doing. It's pumping heat out of the air. So in the winter time, it's pumping heat out of the outside air, which is a bit counterintuitive because it's cold outside, but there is still heat energy in the air. So it's concentrating that heat, separating it, moving it inside, and blowing the hot air inside. And then in the summer, there's a thing called the reversing valve. So it will reverse directions, and it pumps heat out from the inside air and rejects it outside. So
Right.
effectively creating air conditioning.
Right. But I mean, it is amazing that you're doing really big buildings. I mean, so you're putting, when you do I mean, I don't quite know what the housing stock is like in Canada, but I mean, presumably a large tower block I don't know, has it got hundreds of apartments or has it got many apartments in it, presumably?
Oh, yes. There's, in Home Court, Ontario, Canada, there's about 400,000 electrically heated apartments alone. There's way more apartments that are gas heated. So those are the two types of buildings that we work in,
Right.
electrically heated and gas heated. There are benefits to both, and the business case is a bit different. But
Right.
yeah, there's hundreds and thousands of buildings in
Yeah,
the market.
and if you think of the market, you can't think of it as the Ontario market. It's the Ontario. It's a Northeast North American market that sort of runs from Toronto all the way down to New York, Chicago, and the tri-state area. And there's a lot of political movements and carbon fines that are happening in the U.S., especially in New York with Local Law 97, where landlords are really motivated right now to retrofit and lower their energy exposure to carbon fines that are happening, which is called Local Law 97 New York.
Right.
And there's the IRA and tons of incentives. And then in Canada, there's also a lot of incentives, and there's also some market movements in terms of how mortgages are done to allow for greening and climate change. So part of our job is to really thread all the different technologies, the decarbonization technologies, to electrify a building, and also the financial instruments to allow the building owners in order to execute on the adoption of heat pumps and other energy efficiency equipment. So we really handle it all. It's a full turnkey process from identifying the values and then doing the energy calcs and then the installation.
So, and with when you convert a building like that, I mean, I'm assuming that your insulation in those buildings is pretty good, but do you ever upgrade that, or do you need to do that, or generally is the housing stock in Canada fairly well insulated?
Yeah, I think the biggest thing that we look at is windows and upgrading windows, because typically we're in an old building. Maybe it was built between 1920 and 1985. They might have original single pane windows, which have huge heat loss value. So you're just bleeding heat energy. So sure, if you upgrade the efficiency of the equipment, that's great, but you'll get way better efficiencies if you put a double pane or a triple pane window in tandem with the HVAC retrofit. Because then you can put smaller heat pumps in. It'll use less energy overall. So windows is the biggest thing over insulation, I would say.
Right. Because I mean, I think that's what we're also cursed with in this country. Is our old buildings are really old.
Yeah.
The neighbouring building I live next, is on the other side of a little valley, was in the Doomsday Book, which means it was there in 1066. So they didn't do a lot of insulating then. Don't think. But that is, that's a big challenge we have in this country, without question. Is that's got to be the first step. A lot of our housing is Victorian, which means it's everything about it is a problem. But when it's on that scale, though, because I don't quite understand the sort of economics of the housing system in Canada. So if you live on the 10th floor of a big block and you've got an apartment there, who won't that you don't own that building? You presumably have some form of lease on that.
Sure. It's very similar. So effectively, there are apartment buildings that are owned by a landlord, and tenants lease space, and those are apartments. And then there's also condominiums where people own apartments as well. They own that box in the sky, which you have as well.
Right.
And it's the same pretty much in the US and Canada and in Britain and on the same process. But you brought up a point. The person that's actually making that decision to retrofit that apartment unit is the building owner.
Right. Yeah, that's what I was asking. Yeah.
And that building owner has a different set of decision-making processes than let's say, an owner of a condominium,
Right.
because they're managing an asset, and it's a concept of value for them. So if you're retrofitting a building, how does that impact the value of my building?
Yeah.
And it may impact it negatively on day one, but not on year 3.
Right.
Right? So the idea is that you are generationally changing the heating system in the building, and that's a big decision.
Yes.
These are large executives, and nobody gets fired for doing nothing. So
Right.
they when they come to it, they have to come to it with full eyes open, knowledge, all of the details buttoned down before they can say this is something that we're willing to invest in.
But I mean, presumably, the two things I want to know is, but one of the things is, I'm assuming the economies of scale. If you're converting one house, you've got to go to that one house with a team of engineers. You've got to install things. There's costs built into that. But if you're in a building with 100 houses, presumably it's a more economic prospect for that landlord.
Yeah, definitely. I mean, they're going to get better pricing on the equipment with volume, of course,
Right.
and deploying the labor and the resources to implement that project. It's complicated. There's a lot of trades working: electricians, refrigeration techs, movers. But definitely, there's economies of scale in a larger building. So
because the other question I wanted to know is there's an apartment building I know well in London that has one enormous gas-fired, like a furnace or a boiler that heats that runs a hot water heating system around the house, around the building. It's a big building. So would there be similar installations to that in Canada and North America? In USA?
Absolutely. And I guess just to highlight, the reason why this is important, and it's not something many people often think about, but greenhouse gas emissions come largely from buildings.
Yeah.
Transportation, agriculture, these are all huge industries that contribute a lot of GHG emissions, but buildings are another one. And it's the burning of natural gas or oil or space heating and hot water. So that's why it's important to switch to an electrified heating system with a heat pump, which is very energy efficient. So those gas heated buildings, we're doing a lot of those. We also do a lot of buildings that are electrically heated with, electric baseboards. And that's just a very inefficient way to heat a building, and 3 times more efficient to do the same thing with a heat pump.
Yeah.
So that's where the industry is trending. It's a quicker payback and easier install for the electrically heated buildings. The gas heated ones are more complicated. There's a lot of challenges and a lot of hoops you have to jump through to make it happen technically. But
whether you're sitting in St. Albans, London, New York, or Tokyo, if you have a gas heated building, you've got to go to your utility provider and you've got to say, hey, I need to increase the capacity because that building, when it was built, had gas carrying the heat load, not electricity. So they typically don't have the capacity in order to install heat. So
they wouldn't have the electrical capacity.
Correct.
Right. Yeah.
Correct. And that's the biggest challenge. So you'd have to go to your utility provider and you'd say, hey, I need to increase the capacity. And your utility provider will say, okay, that's $500,000 because you need to increase it from the transformer to the property.
Yeah.
You would say, well, why is it $500,000? And the utility provider would say, well, it's $500,000. And that's not quite true. I mean, there's a lot that goes into it. We know that there's something on the pole. There's this. It's upfront capital cost in order to increase capacity, and we're not talking about generation. So forget about how much more you have to generate, but it's really on the microgrid, right from what's happening outside of the building and how do you increase that capacity in order to electrify. So if you think of a city like New York, which is all steam and gas heat, every one of those buildings, really could use an increase in capacity in order to remove gas, where there's a huge demand for that. So, and that's the holy grail, is actually retrofitting gas heated buildings to heat.
Yeah.
And we're doing it.
You're doing it. Oh, it is amazing. But I mean, I think one of the things I always have to say when I talk about this stuff is, people go, oh, well, if you're just converting it to electricity, all the electricity is dirty because you make that from burning coal, that argument. And I think it's important. I always want to underline the fact it can be made by burning coal, but it can also be made by a lot of other things, whereas you cannot use gas without using gas. You've got one choice.
Yes. Yeah.
You know, you've got multiple choices of where your electricity comes from and how you generate it effectively. And
Yeah, every city has a different, cleaner or dirtier grid.
yeah,
So it really is jurisdictionally impactful on how that city creates its energy.
yeah.
So if they use gas or coal, then yeah. If they use nuclear and hydro like water, then it's a lot.
Yeah. Well, I know Vancouver, you know, having spent some time there, and British Columbia is very heavily hydro-powered, or certainly has been. And, you know, so presumably if you're converting from gas to a whole building from gas to electricity in British Columbia, the advantages are pretty huge.
Yeah, and they really want it. They're amazing out there.
Right.
They've called us and said, like, you need to be here. You need to do your business here.
Right. But I mean,
And
that's really interesting. So you've absolutely focused on large buildings. It'd be good to talk about I don't know what to call, I don't know the term, non-habitable buildings you don't live in. Because you're also doing like office blocks or public buildings, or what other types of buildings are you doing?
Yeah, we've done some smaller commercial buildings. You know, our focus really has been apartment buildings.
Oh, it has. Okay. Right.
And the reason is it's the largest impact we can have, you know, for any one particular project.
Yeah.
So that's where we've invested our resources and our business focus to date. You know, we're growing. It's not to say we won't continue to hire great people and build out, you know, more divisions to have different focuses, like getting into single family homes or to focus more on the large commercial office space.
Right.
It's been interesting. I think there's, of course, been a lot of vacancy in these major cities and office spaces right now. And with what we've all gone through the last few years, COVID, but, you know, people always need somewhere to live. And, you know, people want air conditioning as well, where air conditioning is becoming a health and safety concern and more of a must-have as opposed to a nice-to-have when you're looking for a rental apartment. So there's a real big demand for what we're doing in that space. And
right. Because the other thing I thought of, I hadn't even thought of it when I first knew I was speaking to you, but I was just reading about the truly shocking forest fires you've had in Canada in recent weeks. And it was brought to my attention by a friend of mine who lives just north of Manhattan in New York State, who's just posted a picture. I know the view out of her window because you can see the Hudson River. It was just sort of yellowy brown. There was nothing. You couldn't see anything. And she said, and I said, is that a local fire? And she said, no, it's in Canada. And I went, oh my Lord. That was well, the question is, does that, if you live in an apartment with a heat pump and say it's in the summer like now, and it's pushing in cool air to keep you cool in your building, and you keep your windows shut, does it filter that air? I mean, is there an element of that where the air is cleaned a bit?
Well, it's interesting. Yeah, with your windows shut, there's actually no air transfer from outside to inside.
No. Yes.
It's refrigerant. So very small refrigerant pipes connect the outdoor unit and the indoor unit. So you have the outdoor air is sort of being blown over the coil by a fan, and then the indoor air, same thing, being blown by a fan over the coil. So it's just your interior air recirculating. So if your windows are shut, it's not like the smoky air is coming inside.
No.
It's working a bit differently.
Yes, thank you for explaining that, because I'm now so ashamed because I actually knew that, and it's only when you said it I remembered and I went, oh.
But it's funny because fresh air is something that we do handle.
All right.
So that's part of this. That's part of the thread of technologies that we bring in decarbonization.
Right.
And along with water conservation and EV charging and solar. So we have to loop it all in together, but it really starts for us with the heating.
Oh, so if you were doing a building and the landlord wanted you to go the whole hog, do everything, is that a thing you would install electric vehicle charging as well in their car park or whatever?
Yeah. Oh yeah.
Oh, that's good.
Yeah, and the biggest one also that's got for us is the domestic hot water. How to take off of gas also.
So because that's not done by the heat pumps then, the hot water.
Well, there's a couple ways to do it. One's a centralized system, one's a decentralized system, and again, it comes down to capacity because where is the electricity coming in from, And if you have to bring more electricity and you want to bring it to a central point, so then you end up on the central system with a heat with a water source heat pump and different technology to bring up the heat and storage facilities. Oh, and one of the companies you once did an interview for, SunAmp, is part of that solution. They're fantastic. So we're having a lot of bringing those technologies to be able to bring that heat in. And it depends on a building. It's you asked a question. It's like, well, we have to see the building. Come up with a solution.
Yeah.
And
that's it. So would you say then, in the grand scheme of things, heating hot water is more of a challenge for you than heating space?
I think,
or is it just different?
Yeah, it's different. I think the solutions for domestic hot water and decarbonizing those systems, it's a little bit behind where we are with, heat pumps for heating and cooling.
Yeah.
Heat pumps have been proven for heating and cooling for decades now, especially more so in cold climates over the last, decade. So we know it works. There's a lot of projects out there that we've done that are proven, been operating for years. In domestic hot water, it's a smaller fraction of the overall sort of GHG emissions of a building. The largest piece of the pie is heating, and domestic hot water is sort of the smaller sliver.
Right.
So it's important, and we're going to address it. We are, but the need for it in the market hasn't been as fundamental as heating to date.
Because I think I can understand the rudiments of the physics of how it's easier to heat hot. You're heating hot water in an enclosed space, and you can store that heat much easier in a tank, and all that stuff is a lot easier than heating a big room. I'm guessing.
Yeah, and you have to heat water to a certain temperature to get it very, very hot, so that it's safe for domestic potable water. Right? If you don't get it hot enough, then the tanks can grow mold, or it can be unsafe. So it's critical to be able to get that water hot enough and to keep it hot, and that's where the technical challenges come from.
Right. And I mean, because I really haven't got any idea of this. Well, the two questions I really want to ask is the scale of what you're doing. I mean, do you feel you are making a proper dent in the sort of?
I mean, we hope so. We're chipping away. We're heads down. We're building a great team. That we're all in this together, and we always say it to ourselves and to our team and our customers. It's one heat pump at a time. One building at a time, and it's really a ground game to go out there and you can talk about solutions, you can talk about policy, but it's going to take industry and companies like us actually in there and educating landlords and educating the market and getting projects contracted and executing on them, one unit at a time. So it's a tall task. There's more work to do than it seems like it's an insurmountable task for how many buildings need to be retrofitted in the next 50 years, but we're chipping away.
Yeah.
So
and I mean, I'm wondering if, because one of the anecdotal bits of evidence we have about electric vehicle adoption, which was a study done quite a while ago, but it's been proven again and again. So one person in a street gets an electric car and all the neighbors look at them and think he's bonkers or she's an idiot. Why has she got one of those? They don't work. I've seen them talk about them on the TV. They don't work. And then 2 weeks later, she's still driving. And then a month later, she's still driving. And then one other person gets one. And then there's two of them in that street. And we know of streets where one person had one for a year and within 4 years, 22 people have them. And I'm wondering whether if you've got a landlord who's a bit skeptical and you take him then to a building that you've already done and you show him the spreadsheets and this is what it costs, this is what the savings are, blah, blah. That's got to be a help, I'm guessing.
Totally. And we do that all the time. I think in the early days, we did a lot of pilot projects with owners that maybe didn't want to commit to doing 200 units all at once. Fair enough. We said, okay, let's do 2 units and we'll put some measurement and verification meters on those units. So we'll measure and verify some baseline units that we didn't retrofit. And we'll track it for a year and show you the savings. So we did that, and then that translates to a full building retrofit when they see the results. And then for other owners, I know, take a little bit longer to make, this transition. For sure, we'll take them to one of our project sites, let them chat to the tenants. How do you like the equipment? How does it look? How is it working? show me the data. And yeah, we do that all the time.
And that's got to be one of the advantages of the fact that it's a modular system, that you could go in a building that has 200 apartments, you just put one in. It's not going to.
Yeah. Well, trust is you're bringing decarbonization for us is about trust.
Yeah.
Where you have to trust that this technology is going to work. You have to trust that the people that are going to install it are going to install it well.
Yeah.
And do it properly. And I can tell you, things go wrong all the time.
Yeah,
sure. You're drilling away, and all of a sudden, particulate starts coming down. And you're like, oh no! And then you have to solution it, or there's a wire that's not supposed to be there, and it gets cut because it wasn't on the plan, and you need a solution. So solutioning is what we do, and we're doing it at a both on a ground level basis, building unit by unit, but on a building by building basis. So it grows, and we've got to take these macro ideas of government and corporations of net zero and decarbonization and really make it happen on the ground. And that's
certainly one of the big problems that I've discussed both in Australia and this country, I know also in many European countries, is the skill shortage. Because what you need is a lot of people who are skilled at doing installing heat pumps. It's not something you can get. It's not like painting a wall. It's a little bit more involved. Although my son was a house decorator for a while, and he would claim that it is a skilled profession. I must remember to say that.
Absolutely. Yeah. Skilled labor is hopefully, I anticipate it will become a bottleneck, unfortunately. Hopefully that won't be the case, and the younger generation will be more incentivized to get into skilled trades and consider that a serious option, as opposed to just university, which has been the standard track for, a lot of kids decades. But we haven't hit our capacity yet. We have a lot of great teams of all different contractors in every city we operate. So we vet them and we train them up on how to work on our types of projects, and they're very, very skilled and experienced. So we haven't hit our capacity yet. We might in the future. I don't know when that will happen, but I think it's important just to keep putting the message out there that, the next generation should consider skilled trades. It's a great job, great pay, a lot of work to do. You'll never be without a job if you learn how to install HVAC or refrigeration or be an electrician.
Yeah.
Yeah, and I guess what we do is usually at a higher end in the sense, not cost-wise, but we're doing large buildings and we're working with larger companies that come out. And we come in with a big group, so it helps.
And I mean it must be. I'm intrigued on the kind of level of. I'm trying to think of the word, but if you live in an apartment and your landlord says we're going to install heat pumps, and you're cooking your breakfast one morning, and then 20 blokes turn up with boxes and drills, and I don't know. I mean, presumably you're doing this while there are people inhabiting the spaces.
Yeah, most of the time the buildings are occupied.
Right.
But we work very closely with our customers and with the building staff on planning. These are planned projects. It might take 3 months from start to finish. It's not like we get a contract signed and start tomorrow.
Right.
Usually 2-3 months out. So that gives us a lot of time to plan and schedule and work with the building. We put out notices. We do training sessions. We let everyone who lives in the building know what's going to happen, what the benefits are to them, what to expect, showing them where the equipment's going to be installed, canvassing the units, talking to residents if they need help with moving furniture out of the way, or if we need to adjust based on, any particular layout. And we'll say, okay, we're coming into your unit next month on this week, and then we're coming on this day. And we're really good at being in and out of one apartment in one day, because we understand that people live here and we don't want to be in your space for 4 or 5 days. That's really disruptive. So we put a huge importance on being efficient, being quick, being in and out in one day, and working closely with the building to make sure it goes as smoothly as possible. Mm-hmm. And I think that's one area where we shine.
Tenant management. Yeah, again, you don't know sometimes you don't know what you're going to get when you go into an apartment, and our installers are trained on tenant management. If somebody says something or they ask a question, or if the unit, you walk in the unit, you just can't work with that unit, and what do? And so we're good that way.
Yeah.
Yes.
And then what I guess quite a very important question is the running costs, because I know about the installation costs and all, but if you cut that out, particularly in this sort of situation, the actual individual person that's living in that apartment, will they have will the cost of running it affect their monthly outgoings? I don't know how will they have an increased bill or a decreased bill, or is it stays the same, or how does that operate?
It depends.
Yeah, it depends.
Right.
Yeah, some buildings have individual meters for each unit, and tenants pay their own electricity bill. Some buildings don't. If the tenant's currently paying their hydro bill and they have electric baseboard heating, then their costs are going to come way down.
Right.
So it depends.
Yeah. That's But then, on a general level, is it? Because I'm trying to think of the examples I know here and whether they relate to what you do. But on the people I've spoken to who've replaced gas heating with air source heat pumps, that it is cheaper. So even in this country where our electricity prices have gone spiked, they're actually coming down a bit now, but they did go up really high. But it was still cheaper to use a heat pump than to burn gas.
So each city determines how you can charge for heat.
Right.
And it also comes down to the contract and lease that the tenant signs. So when you change heat with sitting tenants, it could be a different conversation than with new tenants coming in.
Right.
So, and again, we go back to this gas electric type of building. On the electrically heated side, and I think you'll love this because I've watched your show many times.
Right.
But if you can retrofit a electrically heated building, you could drop the electrical capacity load down by 50%. So
when you fit heat pumps, wow, okay,
that's times more efficient.
Right.
So if you took a 100-unit building, you could effectively, with load software, you could put in 2 EV charging stations for every apartment you retrofit. So in a 100-unit building, you could have 200 EV charging stations.
Wow.
You don't need 200 right now.
No.
But that is so there's that heating, that electrical bill will come right down.
Right.
Either for the landlord if it's a bulk meter, or for the tenant if it's on a separate metering basis.
Right.
On the gas heated side, eventually over time, the tenant will be paying the electricity costs as new tenants come in for the air source heat pump, because you'll be eliminating the gas, the central gas.
Yeah, and it's a function as well. The utility price for gas and electricity in your area, so that's different all over the world. And historically, in a lot of markets, gas has been cheaper than electricity for space heating. So in the past, it was cheaper to heat with gas, but when you factor in carbon fines, taxes, penalties now, as government's moved to lower GHG emissions, it's going to be, and is already in a lot of markets, cheaper to heat a building with a heat pump than it is with a gas boiler.
Right. Yeah. And I mean, what I'm assuming though is that isn't your main motivating factor that you would argue with the landlord. It's not. It is about cost, obviously, but it's also about what that building then generates in terms of CO2 is massively reduced if you've got air source heat pumps rather than gas.
Yeah. Okay. So energy managers talk the language of kilowatt hours.
Yeah.
And your government talks the language of constituents and voters, and HVAC talks the language of equipment, but building owners talk in the language of value. So at the end of the day, they have to cover their mortgages and cover their expenses and have a value for the building. So when we're having a conversation about retrofitting and decarbonization, you also have to be having this conversation about value, because they are the ones that are going to be signing at the bottom line to decarbonize. Right. It's not the individual tenant, it's not the government, it's not the HVAC company, it's not the energy manager, it's that building owner. So, in this sliver of sector in the world, it really is up to that building owner and to do it. And you find that the institutional landlords and the pension funds, they have energy managers there whose job is to get their organizations to net zero. So they're really motivated to engage companies like ourselves in order to decarbonize the building and to make it more efficient, and also be able to go back to their bosses and say, look, we can do this because it will be over time. This is going to be the payback in 5, 10, how many years?
Yeah.
On the smaller landlord, they have less access to financing and the dollars required to do it. Not that they don't, but it's just not as much as the institutional. They don't also have the sophistication. They don't have the energy managers. And you'll see that there'll be a lot more city and government intervention to incentivize or to, have a stick to get the smaller individual landlords to retrofit. And we're there for them as well. Like, we're a huge resource. Like, what do I do? Right. So, for example, in New York, every building has an efficiency rating over 25. Every building has an efficiency rating, and everyone over 25,000 square feet will be given a fine if it doesn't meet the right efficiency after 2024.
Right.
And all of a sudden, everyone's saying, "Well, okay, I have an efficiency rating. What do I do?" And that's where conversations with Bondi Energy comes in.
Right. Because I've not had the privilege or pleasure of coming to Toronto, but I've spent quite a lot of time in New York and in Manhattan, and I know how big those buildings are. Because I think that's what fascinates me. When I see my friend down the road who's got an air source heat pump, it's on the scale that you're talking, it's so tiny. And when you look at these, from my old school European views, huge buildings, I just can't imagine. And I have visited one friend, a guy I work with. I went to his apartment, and he was on the 40-something floor, I think, of his quite spacious apartment. And I was scared to go near the window. I mean, it was just huge.
Well, yeah, we use different technologies. It's not just an outside condenser with splits, which is what we could do when you have balconies, but we use through-wall heat pumps, and we use VRF systems, and we're agnostic to technology.
Right.
It really is what we work with. We have technology that we depend upon, that we've used over and over and over again because we know it is the best. But we really are looking for the right solution when we walk into that.
So just in that particular case of this apartment I went to just many years ago, I wasn't there very long, but they didn't have a balcony. They just had windows. So if you are that high up, you presumably have to get something outside the building to make I don't know, how do you do that? I mean, have you ever dealt with a building of that type?
Yeah, we, like Aaron mentioned, we have a different type of heat pump technology that we use sometimes, and it's been a great tool for us. And it's a through-wall heat pump. So it's effectively self-contained into one box, similar to a PTAC that kind of goes through
a hole in the wall.
Yeah, so this, there's one manufacturer that we use out of Italy, and it's a beautiful product, and it's very efficient, and it's modern and streamlined, and it looks great, but it's all self-contained. So the compressor, the fan, all the parts are in that one unit. Right. Put it on the wall. It has some vent holes for air to the outside, but you don't need a separate compressor. It's all in one.
And you don't need someone outside the building on ropes or on a scaffolding or whatever.
Sometimes we do. Again, if the building is brick, is it window that we're going through? So.
Right.
And we've installed thousands of them in the Canadian market. We just installed a number of them on the Upper East Side, in New York, and in Chicago, and it's been very good.
Right. Yeah. That is amazing. It's an incredible thing you've done, and I don't know why. It's my ignorance, but I've never come across it before. It really caught my attention when I heard about what you were doing. Because I think all the focus in this country is on insulation before anything else, and that's the struggle we have. So I've not even thought about. We've done a couple of programs about a couple of shows about systems where there is a centralized ground source heating system that heats an apartment block, but that's very different to because is there an air source solution that would be that you could. I mean, this is a silly question. I should have done the research, but where you could take out a big gas heating system and replace it with an air source heating system that then heated I'm running out of information how heated the whole building. But I mean, because what you're doing is individual heat pumps on individual apartments. There isn't a sort of centralized, big, huge heat pump,
Well, yeah,
400-ton one that you can put in a building.
yeah. Well, there is.
Oh, right.
Yeah, it's called, and we do this as well. It's just one of the tools in our toolbox.
Right.
The building needs it, so it will be called a VRF system, or a variable refrigerant float, which is a large central air source or water source heat pump system. So think, just instead of individual small compressors for each apartment, you have fewer, bigger compressors that maybe go on the roof or
Right.
in a bank beside the building or in the parking garage. And then those now feed into each apartment.
Right. Oh, so there is that alternative, right?
It's hard to retrofit a building and install a geothermal system because typically the pipes are dug into the ground underneath the building. So for new construction projects, it's a great option, but retrofit.
Because that was really my last question, was about new buildings now. Because presumably there are apartment blocks being built or new big buildings being built in the area that you work in.
Mm-hmm.
Are you involved in putting in heat pumps in new builds? Because that's got to be the time to do it in a way.
Yeah, sometimes most of our businesses still retrofit, but
Right.
do some new construction as well.
Because that's presumably, I mean, what would your solution be? Say you were going to build a 100 apartment new building and you had permission, you had the budget to do it. What would your suggestion be for the best way to heat that building? Would it be ground source? Because if you're going to have a big hole in the ground anyway, you could just drill a bit further. I don't know.
Yeah, I mean, again, it depends on the goals of the developer and, their capital budgets. Geothermal is much more expensive upfront, has better efficiencies long term, but water source VRF or air source VRF is what we probably suggest on new construction. You're building from the ground up. It's a lot easier to run your piping and to install a central
system. Or decentralized system. I think that's another is decentralizing the to each apartment in terms of the heat pump and the hot water means that each unit can determine its own usage. So if someone's not there, you can turn it off. Another part of what we do, which is, again, you can do it right out to the EV chargers, but we also have building automation systems that we can control the heat pumps of each individual apartment. And that allows us to drop energy when we have to drop energy. So we can participate in demand response, and an asset manager can control across the whole building. And that could also tie into chargers, other sensors in the building. And I think that's a big part of what the future of install of retrofits will include is building automation systems.
Actually, that's a really good point, because that was an experiment I took part in last winter in the UK. Was a demand response thing, which was run by one of the energy suppliers, and it was extraordinarily successful because they thought they'd have very minimal response, that not many people would want to get involved, and they had an enormous response, and it was gigawatts in reduction in demand at peak times. And it's that simple. It was only an hour and a half. It wasn't like a day or 10 hours. It was just a couple of hours in the evening, and it meant we didn't turn on gas peaker plants or burn coal, it really made a big, and it kind of got people's attention and got in the news. It got it was on the radio and TV news that there had been this massive reduction in demand because people said, okay, I won't do my washing or run the dryer right now. I'll leave it for a bit. That's that.
Yeah.
They did actually have the lights on, but then presumably, so if you've got a warm apartment and you turn off your air source heating for an hour, you don't freeze to death.
No, there's the residual heat. It takes time to leave. You can crank the heat by a degree, an hour before that peak period. And then you have that residual heat that will tide you through.
Yeah.
And you can think of demand response. If you have 200 unit apartments, you can reduce the energy to 10 apartments for 20 seconds, and then another one for 20 seconds, another one. So you actually have the ability to move energy around in a building, which is also part of that demand response.
Yeah. And you wouldn't even know then, as an individual tenant in that building, you wouldn't even know it had happened. Yeah.
Yep.
That is, it's really, I want you to tell me if there's some major thing that you're doing now that I haven't asked you about, because it opens up so many different ways of thinking about
Well,
the
I
way
think at
we
the very
live.
beginning, like how I said it, we're threading all of these technologies and applications together. Some of them are cottage industry, some of them are massive,
Yeah.
and we've got to bring them to each individual building. So yeah, I mean, the BAS system is really a lot of fun. I think that's going to be.
Yeah, we're pretty excited about that. There's few options in the market that can do what our system can now do, and we're
And I think if there's more, one of the comment about a year ago was there's just a lack of decarbonizing kit.
Yeah.
And we're continually innovating. We're looking at batteries and how do we, if we're dropping the capacity, electrical capacity of the building by 50%, well, that building still has that capacity. So
Right.
how do you arbitrage that opportunity for, using that in off-peak hours and bringing it back to the grid? We haven't touched on that stuff.
Yeah.
There's water conservation, I think, is a really big one too, which is, there in your house, my house, in every city at night, the water pressure increases and your toilets leak. Everyone does. It's called ghost leaking. And there are now
because no one's using water, the pressure.
So I mean, we can save 20% of a water bill of a massive building. I mean, that's tens and hundreds of thousands of dollars.
Right.
And I mean, so that's another one that's really a lot of fun too. And
that is brilliant. I never knew that. I've learned something today, and all I can say is that as an older gentleman, I'm actually helping to slightly lower the high water pressure at night because I have to get up. And which I didn't use when I was a young man. I never got up, but now I have to get up in the middle of the night.
That's a great.
But that is fascinating because you're. Sorry, I'm not going to get too obsessed by that. But we've got one of our toilets in our house leaks at night, and it doesn't in the day. And I'm baffled, and I'm going, "Why is it leaking?" You've just explained something. I never knew that. It makes complete sense because presumably the water system has to have pressure to make it work, and particularly to get it up in a high building.
So
and
imagine 500 toilets not doing that.
Yeah. Basically, what every apartment needs is an older gentleman with slightly. Shouldn't have gone there. Sorry.
No. So I mean, that's why we're called Bondi Energy. Like, we're an energy company, and in the context that we do retrofit multifamily commercial buildings with heat pumps. That's where we start, and other technologies, and the idea is to provide those decision makers with a full turnkey process that can start at the top with the financials, do the energy and heat loss calcs, the engineering, full install, tenant management, aftermarket service.
Yeah.
And when you have to, it's a long path view. Like, if we're gonna change, it's gonna take more than one lifetime to impact these. To make a change to what we're doing. We're not going to solve these in an individual life.
No.
So that concept of generationally changing that heating system in a building is a very big step for a lot of people.
Yeah.
So we want to make sure that we're able to say, look, this is how it's going to happen from beginning to end, and we have the ability to do that. And Belinda is right there in front of all of it. She's the president.
Right.
We're a women-led green tech firm growing across North America.
So we're doing it together, and we're having a lot of
fun. That's very generous, Belinda, but I can tell you are the boss.
Oh, thank you.
That's fantastic. Guys, you have been so kind, so patient with me. We did struggle a bit to get this done, but that has been faultless recording. Thank you so much. It's been a real joy, and I've actually learnt some things, and your explanations have been really clear, and I'm sure our audience are going to absolutely love it. So, serious thank you for taking the time to talk to us.
Thank you so much, Rob. It's been a pleasure.
And good luck with all your future projects.
Well, thank you. Maybe we'll see you in Canada.
Well, I really hope you enjoyed that. I think it's fascinating challenges they're coming up with, amazing solutions. We'll put all the links to Bondi Energy because it's worth having a look at their webpage. They are doing some extraordinary stuff. They're developing new technology, as they said. We barely scratched the surface of what they're up to, and they're clearly going to be doing a lot more really interesting stuff in future. So we will update. We'll keep in touch with them because they're clearly a company that are going places. Anyway, that's all. I've done all the other announcements at the beginning. I can't remember anything else. I'm sure I've forgotten something. But, that's just an age thing. I just want to say thank you very much for being with us today. And as always, if you have been, thank you for watching.